Are we ready?
Ready.
Okay, Chem Studies kids, this is a demonstration of how to do a titration, the titration that you'll be doing in class yourselves. Step one is always put your goggles on for safety. We're working with acids and bases, and both of them will hurt your eyes if they get in them, so make sure that you have your goggles on before you do anything. Okay, I have a data table set up over here that you will have in your lab notebook ready to go. And the very first thing we do is record the molarity of our base. So looking at the data table, our acid is here, HCl. We know it's an acid because it has an H in front of it. Our base is over here, NaOH, and we know it's a base because it has an OH at the end of it. The first thing we have to do is write down what the molarity, the concentration of the base we're using, is going to be. And in this case, our molarity is 0.18 molar. Now you might ask, what's the molarity of the acid? Well, the molarity of the acid is what we're trying to figure out. That's the whole point of the titration. So I'll just write in here for molarity of acid what we are figuring out. Okay, so we've got our data table set up and ready to go. This is the equipment that you'll be working with. We have two burettes, one for acids and one for bases, and we have to be really careful to make sure everything is labeled so that our our acids are separate from our bases. You'll notice I have a funnel labeled A for acid, the burette is labeled A for acid, the beaker that holds my acid is labeled A for acid, I have sort of a catch beaker that's labeled A for acid. Don't confuse any of your acid and base equipment, otherwise you'll mess up your calculations. Okay, so I recorded the molarity of my base. The next thing I want to do is fill each of my burettes with the appropriate solution. Now notice the burettes are closed when the valves are perpendicular to the burettes. You want to make sure that the valves are closed before you start pouring anything into them, otherwise if the valves are open, the liquid will just leak out as you pour it in. So I'm going to carefully take my burette out, and I'll take my acid and pour it into the funnel, being careful not to drip. And I want the level of the acid to go almost to the top, but I don't want it to go higher than the number lines on the burette. I don't want it to go beyond the measurements of the burette. So I'll fill it up to about there. And now my burette is full, but the bottom part of the burette still has air in it. So I want to make sure that I have acid in this little bottom part of the burette too. So I'm going to put an empty beaker marked A for acid underneath it, and I'm going to open the valve, let some of the acid out, and then close it again. And now I have acid in the burette and in the tip of the burette as well. I'll do the same thing for my base. Take it off the stand. Make sure that the valve is closed. Pour the base into it. It can be tough not to splash, but I'll be careful. Another reason why I'm wearing goggles, because I might splash. Oop, there, see? And once again, I want to make sure that I let some of the base out the tip of the burette so that there's no air in the tip. So I'll put my catch beaker labeled B for base underneath it, turn the valve up and down for open, and you might see little bubbles in there too. You can kind of tap your burette to get rid of the extra bubbles. There we go. Okay. So I'll move my catch beakers over here so they're out of the way. and I'll move my source of acid and base out of the way. I've got some splashes here. I want to be good about keeping my area clean, so I'm going to wipe up my splashes before I do anything else. Oops. All right. The next thing I want to do is read both of my burettes. I want to know what the level of base is and what the level of acid is. That's really important data to write down. So let's start by looking at my acid. I hold the burette at eye level so that I can look closely and see where the bottom of the meniscus is. The bottom of the meniscus is hitting, it looks like at 3.4, between 3.4 and 3.5. Well, yeah, so 3.40, actually right on the 3.4 mark. I have to record that in my data table, and it's really important for accuracy that I record it to 2 places past the decimal. So if it's sitting right on the 3.4 line, I'm going to say 3.40. This is for my acid, my initial volume of my acid. 3.40, and the unit is milliliters. If you don't record your starting volume, you'll mess up your whole titration. You'll have to do it all over again, so make sure you do this. For my base, again, I hold the burette at eye level. This time it's at it's between 7.0 and 7.1. So I'm going to write, since it's between 7.0 and 7.1, I'll write 7.05 milliliters. 2 places past the decimal for both of them. This piece of equipment is very accurate, and we want to reflect that accuracy in our data. Okay. This thing is called an Erlenmeyer flask. I want to place my Erlenmeyer flask underneath my acid. So again, make sure that you have the acid in the acid spot, the base in the base spot. I'll scooch this up a little, and I'll place my flask underneath the acid. I want about 10 milliliters of acid to go into my Erlenmeyer flask. So what I'll do is look at my burette. My initial volume is about 3.40 milliliters. So if I let 10 milliliters go into my Erlenmeyer flask, that'll be about 13.40 milliliters. So what I'll do is I'll move my thumb down to about 13.4. It doesn't have to be exactly 10 milliliters, so kind of about. And then I'll open the valve, and I'll wait for the level of acid to drop down to the 13.4 spot, about. And if I mark it with my thumb beforehand, I just wait for the meniscus to get right to my thumb, and then I'm good. So I've put about 10 milliliters of acid into my Erlenmeyer flask. Okay, this is our indicator, phenolphthalein. I only want about 3 drops of it in the flask, so I'll slide this up, pull my flask out. One, 2, 3. 3 drops is plenty. Now notice, if I place my flask on a piece of white paper, it's still clear. That's because phenolphthalein doesn't do anything in an acid solution. It's going to turn pink when the solution turns slightly basic. So what I want to do now is place my Erlenmeyer flask on this sheet of white paper, this time under the burette containing the base solution. So let's make a little room for it, slide the paper underneath, and the paper just helps me see the color really clearly. Like that, and I'll turn it so that I can work the valve easily. Alright, I want to make sure that the tip of the burette is inside the Erlenmeyer flask, because that way none of the base will accidentally splash outside of the Erlenmeyer flask and mess with my calculations. Okay, I'm going to add base until I see a faint pink color in my Erlenmeyer flask for about 30 seconds. As long as the pink color stays for 30 seconds, the faintest pink possible. If it fades after 30 seconds, that's okay. I just need it to stay for 30 seconds. If it stays for too long or if it's too pink, then I want to back titrate, add a little bit of acid to it. But this is where the art of titration comes in, is being able to know how much base to add. Now you can see pink color in there, but as soon as I swirl the flask, it goes away. I want to swirl the flask and have the pink stay for 30 seconds. So as I start off, I'm pretty safe adding a good bit of base, because every time I swirl it, it disappears. In fact, I can actually let the base go and kind of swirl as I go like this. And you'll notice it's disappearing. But the more base I put in, the longer it stays for. So as I add more and more base, I want to be careful that I don't add too much. The super bright pink that you're seeing is really, really too bright. Look at that. Way too bright. That's called an overshoot. I put way too much base in there. The pink is much too deep. I want it to be a lot fainter than that. So what I'm going to do is back titrate. I'm going to take my flask, put it underneath the acid, and add a little bit of acid until the pink disappears. Okay, now I know I'm very, very close to my end point, the point where the amount of base is equal to the amount of acid in moles in my solution. So what I want to do is add base, but I don't want to add so much base that I overshoot it again. The way to add a tiny little bit using these burettes is not to go like that, because you can't ever turn the valve up and turn it back again fast enough to avoid overshooting, although it looks like I did there. The way to add base just a little bit at a time is to flip the valve quickly, like that. And then I add a tiny little bit of base, and you can see the color is very, very pink. It's fading. It didn't really stay for 30 seconds though. Let's see one more. So that's probably going to be where I want it. It's a faint pink. It's staying for about 30 seconds. I don't want to add any more base. That should be my end point. Okay, now that I've reached my end point, the data I have to record is the final volume for my base and for my acid in my data table. So once again, I'll take the burette out. I'll hold it at eye level so I can see where the meniscus is. And it looks like it's between 21.1 and 21.2. So for my base, I'm going to write 21.15. 21.15 milliliters. I need to record the same data for my acid. Hold it at eye level, see where the meniscus is. This one's sitting right on the 14 line. So I'll say 14.00 for my acid. Place it back in the clamp carefully. Okay, what I've just completed is one single titration trial. The data that I'm really interested in is the volumes that I actually used of acid and base. And the way to calculate those volumes is to take the final volume and subtract the initial volume from it. So how much base did I use in this titration? Well, 21.15 minus 7.05, I used 14.10 milliliters of base. And this is the data that I'm going to need to use in my calculation. For my acid, I used 14.00 minus 3.40, 10.60 milliliters. I'm going to need this piece of data in my calculation too. There's a third piece of data that I'll need for my calculation, and it's the very first thing we wrote down, the molarity of the base. So these three numbers are the numbers that we're going to need to use to do our calculation, and that calculation is going to help us figure out the thing we're looking for, the concentration of the acid, the mystery concentration of the acid. Now I did this one time. You're going to do it 3 times. You want to do at least 3 trials, and then you're going to average out your answers for the 3 trials to try and get as accurate an answer for the molarity of the acid as possible. So you'll repeat the titration until you have 3 good trials, and in between each you'll want to make sure that you rinse out the flask. You'll want to rinse it out with deionized water. We'll give you squeezy bottles of deionized water to rinse it out with. And then do it again 2 more times, take your data, so you'll have 3 trials, and that's your procedure for your titration line.